Hi, I am Dr. Lachami from the Department of Information Technology, B.S. Abdul Rahman Crescent Institute of Science and Technology, Chennai. I would like to talk to you about the data structures. Okay, in this session, I'm going to take about the introduction to data structures, what are different types of data structures and how data structures are represented in memory. Then we will talk about what are different types of linear data structures like list, stack, queue. And finally, I will explain about what is abstract data type. Okay, let me start by saying about what is data structure. Okay, data structure is nothing. It is a representation of data and different operations allowed on the data. Otherwise, say it is a way to store and organize the data in order to access it quickly and in efficient manner. Okay, it is a method of representing the logical relationships between the data and the solution for the given problem. Okay, next we will see about what are the different types of data structures. Okay, data structures basically is divided into two categories. One is called the linear data structures and another type is called the non-linear data structures. Okay, the examples for linear data structures are arrays, is a very basic representation of the data. Then linked lists and stack and queues. The examples for nonlinear data structures are trees, graphs and hash table. Okay, next we will see in detail about what is meant by the linear data structure and what is meant by nonlinear data structure. The linear data structure is nothing but the values are represented in some linear fashion. Okay, for example, array is one linear data structure. For example, int a of 10, a is an array. So consecutively the 10 locations are located, that is in linear fashion. So if you want to store 10 numbers, integer values, we need some contiguous memory. That's why it's arranging the data in the linear fashion. And then linked list is also linear data structure, and stack is one linear data structure and queue is the another data structure. So generally linear data structure is nothing but the values are arranged in some linear fashion. The next category is called the non-linear type. Okay, non-linear type, no need to arrange the values in some sequential order. So you can store the data in somewhere in the memory. So these are the examples of non-linear data structures. A tree, you know, the very basic non-linear data structure. Your data is organized in branches. Such that we can minimize the searching time with respect to tree. And then graph is also non-linear data structure. The one more example is called the hash table. In hash table, with respect to the hash function, we are going to select the particular location where you are going to store the data. No need the location in the sequential manner. So that's why it also comes under the non-linear. The one more, we can also categorize the data structures in two more types, like homogeneous or non-homogeneous. The homogeneous in the sense, the values of the same data are stored in contiguous manner. For example, if you take array, for example, int RRN of 50. Here RRN is the roll number of the students, so we are going to store 50 roll numbers of the students in sequential order. So all data are the same type, that is integer type. That's why it's a homogeneous. The data values are stored in sequential manner or the same type. That is called homogeneous. Whereas a non-homogeneous is nothing but the data types are different data types. We are stored in the memory. So the examples of non-linear, non-homogeneous data structures are structures and classes. Okay, these are the few pictorial representation of data structures like array, then linked list, then tree, queue and stack. Okay, next we will see about, we will take some data structures, then we will see how these data structures are represented in the memory. Okay, we will see first about the array data structure. All we know, the array is nothing but is a very basic data structure. It is not a new concept actually. So most of the them are using the array. Okay. Without knowing it is a data structure or not. But array is basically is a primitive data structure. It is nothing but collection of related data items or elements of data. So for example, in the RRN of 60, okay, in this particular declaration part, here we are going to allocate 60 memory locations for storing 60 different roll numbers of the student. So all 60 roll numbers are same type, that is integer type. So actually with respect to the memory, we need 120 bytes. Okay, if you take the one integer value, it required 2 bytes in memory. So 60 into 2 required 120 bytes contiguously required for storing 60 roll numbers, students' roll numbers. The one more example is mocks, okay, float declared as float 60. For one floating point value, we required 4 bytes, so 60 into 4 memory is required, and char name of 20. So 20 characters, 20 bytes are allocated. So this is with respect to memory represent. How many memory spaces are required for the array? So array is nothing but is basically a primitive data structure. Next we will see about the structures, how much of memory space are required for the structure is calculated with respect to the structure members. So actually structure is nothing but is a collection of different data items, whereas your array is a collection of related data items. So for example, if you want to keep the data about a student, right, the student has different fields and members. For example, student roll number, student mark, and the student name. So all are different data types. So we need to keep in a single data structure, that is called the structure. So structure is nothing but is a collection of different items then named by a single name as student. So how to calculate the total memory here? Int took 2 bytes and mark is required 4 bytes. Then 20 bytes are required for representing the name. So totally 26 bytes are required for using this structure. The one more important thing is how to access the member from the structure is by using the member operator. Say s of 30 dot orrn is nothing but we want to access the 30th student orrn number. So member operation is very important to access the particular member from the structure. The line shows in green font, okay, is representing the array of structure, that is student s of 60 is nothing but 60 structures with respect to 60 students. Okay, next we will talk about the union. Okay, union is also a collection of different data items, but only slight difference between structure and union is, in case of structure, that is the maximum memory space are allocated. For example, in this case 20 bytes are allocated, whereas in union, okay, if you take the int orrn, it need 2 bytes, float mark is 4 bytes, and character 20 bytes. Among these three, it took the maximum memory space, that is 20 bytes is allocated for the union. So for efficient use of memory, we go for the union data structure. The one more type is called the pointer. The pointer is nothing but it representing the address of the another variable. Okay, let us see with example like int a. Okay, int a is nothing but integer variable. Then after declaring it, we are assigning some value, say 10 to a. Okay, this is nothing but variable. So variable is nothing but is a part of the memory. That particular part a name is having the value 10. Okay, it is nothing but a variable. But what is pointer variable is we can declare by using star, that is the int star p. Here p is not an ordinary variable, it is a pointer variable. So it contains the address of the another variable. Say p contains 5000. Here 5000 is nothing but it is an address, not a value. The next line shows star p equal to 10 in the sense that location 5000 contains the address 10, data 10. So pointer is also is one type of data structure. Okay, here pointer contains the address, not the data. It contains the address of another variable with respect to the memory. Actually pointer, mainly we are using the pointer concept for dynamic allocation of memory, whereas the array is for static memory allocation. So if you want to efficiently use the memory space, we always use the pointer concept. Okay, thank you. Next we will see about list, few more data structures like list, stack and queue. Thank you.